periodic potential, the effective mass of an electron is related to. Now let us see this question. Now before going to this question, let us understand how the electron is moving in a crystal. So electron motion in a crystal. So electrons in crystal moves in a periodic potential. Moves in periodic potential. Now who is causing this periodic potential? Here you have an atom, ion, positive ion, positive ion, positive ion here, positive ion, positive ion. So this will create, so when an electron moves in this direction, the electron will be moving in a continuous and periodic potential. Everywhere the potential may not be same, because the once it starts moving from one end, it will have the maximum potential here, and as it goes the potential decreases, then again potential increase, then again decreases, again increase. So this is called the periodic potential, and this is created by the positive charged ions which is present in the lattice. So it is understood that the electrons do not move freely, no free motion. The electrons, they are not free, they are not free particle, they are bound. Let's say bound in the periodic potential. Okay, now once it moves in this periodic potential, their motion is altered. So the second thing that happens, so they moves in periodic potential is the first point. Now once they move in periodic potential, their motion gets altered. Motion gets altered or changed. Why it is getting changed? This is because at some point it will move faster, at some point it will move slower. So electron motion is altered, and it behaves like as if it has got different mass, because different mass particle will move in the potential at different speed. So as if the motion gets altered, the same particle, the motion gets altered. This means that its mass gets changed. Mass get changed. It is as if the mass is getting changed. So we need to understand that there is an apparent mass associated with the electron motion. So if there is an electron, and this electron's motion keeps changing due to the motion of this electron in the periodic potential, and due to that the mass gets changed. So we have to understand what is that change in mass. That is nothing but our effective mass. Effective mass, you represent it by M star. The formula is nothing but 1 by M star equal to 1 divided by h cross square d square E by dk square. K is the wave vector, K is wave vector, E is the energy, h cross the reduced Planck's constant. Okay, now when d square E by dk square increases, M star decreases. That means mass reduces. That means electron moves faster. When the mass reduces, electron move faster. So d square E by dk square, when it increases, electron motion is faster. Similarly, when d square E by dk square decreases, m star value, that is effective mass, will increase. When mass increases, electron moves slower. Now this motion of this electron depends on what? It depends on EK diagram. Energy wave vector diagram. Okay. One more thing we will add to that. The same concept, that is d square E by dk square for large value. For large value, it will be very steep. The potential will be like this. Okay, this indicates the effective mass is small effective mass. Sometimes we can get question in terms of figure also, small effective mass. So this indicates a small effective mass. Similarly, if d square E by dk square is nothing but the second derivative is small. Small means you have a potential like this. Here you have high effective mass. High effective mass. So if you have a small effective mass, higher conduction. Higher conduction. Here we have low conduction. Conductivity decreases at this point. So this is what is meant by the curvature of energy band. When the curvature is sharp, you have small effective mass. When the curvature is large, you have the low conductivity and high effective mass. So this is what the question actually indicates. The effective mass depends on the curvature of energy band in EK diagram. Now let's understand the physical significance or physical meaning. Now suppose you have an electron here, and this electron has to undergo an energy band in the crystal. So energy band is in the crystal, and if it is very steep, and if the electron has to cross this barrier, there should be some electrostatic force. So some force we have to give, and this force, this electron will react quickly to this force. If you have a very steep curve or a very steep energy band, it will be more pulled towards this the other end. So that's how the conduction takes place. While if the electron is flat, I mean the band is flat, it will be moving very slowly. This is fast motion. Low effective mass. Here it is slow motion. High effective mass. Effective mass is better start writing with M star. Now this m star now indicates a quantity, that is how easily, this is how you can physically identify how easily an electron gets accelerated. Under external force. Now let's take two cases here. So let's start with case 1. What if d square E by dk square is greater than 0? So there are two cases can be there, d square E by dk square greater than 0, and another case here, case 2, d square E by dk square less than 0. Greater than 0 we have already seen what happens when the mass is higher. So once again, so you have the positive effective mass, yes. Now what is the case 2? When d square E by dk square is less than 0. Now this comes in the near the top of the valence band, this energy occurs in the region where there is at the top of the valence band, and wow, this one positive effective mass, we know there must be conducting electrons should be there. So if conducting electrons are there, it should be in the conduction band, which means there are large number of electrons already present, and the conduction band near the bottom of the conduction band, near bottom. So if you take up the conduction band, the electrons will be present here, and below which you have the valence band. This is conduction band, this is valence band. Now coming to the case of d square E by dk square being less than 0, you will have the electrons, or the phenomena will be found at the top of the valence band. So what does this m star indicate? M star is a negative value. So you have a negative effective mass. That means you have some material which will be, when you apply a force, I suppose I am applying an electrostatic force here, E plus, okay. Earlier you had an electron, you have an electric field, it will be moving in the direction of the electric field, correct? Now you have a scenario, you have some charge or some material here. When you apply an electric field, it will be moving away to that. So such material should be positive charge, and since it is positive, we represent it as holes. So when d square E by dk square is less than 0, we have to understand that this occurs near the valence band and the charged particle are nothing but the holes instead of the electron. And in this case itself, we won't represent the effective mass as negative. Effective mass won't be negative, so for we will write d square E by dk square magnitude, and effective mass, so 1 by n star equal to h cross square, sorry, 1 by h cross square d square E by dk square. And if this is negative, we will say it as 4 holes. Now let's derive the equation for effective mass. Effective mass m star. Now let's start with the electron velocity. Electron velocity is the velocity of the particle. Since it is velocity of particle, it is the group velocity. So group velocity v is equal to 1 by h cross dE by dk. Phase velocity we will just write here. Phase velocity Vp will be equal to E by k. 1 by h cross. 1 by h cross E by k. Alright. So V equal to 1 by h cross d by dk. So this is the velocity of the electron. Now let's calculate the acceleration. Acceleration will be the time derivative. So that is A equal to d by dt of v, total time derivative of velocity v. So that will be equal to d by dt of 1 by h cross d E by dk. So let's rewrite that. A equal to 1 by h cross, we can take it out. So d by dt of d by dk, so that is second derivative of dE by dk square into dk by dt, total time derivative of k. But we know h cross dk by dt, h cross dk by dt is nothing but the force, and this is from semi-classical equation. H cross dk by dt is force. Now let's rewrite A equal to 1 by h cross d square E by dk square, h cross dk by dt, right? So let's write h cross dk by dt. So we have added h cross, so let's divide by h cross here, so it becomes square. So h cross dk by dt is nothing but the force. So rewriting that, it will become 1 by h cross d square E by dk square, h cross dk by dt is nothing but the force, and now force is nothing but ma. So a is equal to 1 by, sorry, here we have h cross square, so 1 by h cross square d square E by dk square, and here we have f is equal to m star a. Now we are dealing with the effective mass, so m star a. So a get cancelled, bring this m to the left, so what we get is 1 by m star equal to 1 divided by h cross square d square E by dk square. So it's a equation for effective mass.